Hello Year 4, this is your science lesson for today. Our TLP today is can I identify the effects of friction that act between moving surfaces? So what is friction? What do we know about friction? So friction is a force between two different surfaces that slide against each other. So the rougher the surface, the stronger the friction. The smoother the surface, the less friction there is. So different surfaces create different amounts of friction. And friction is the force that might stop us from moving. Let's think about Paradeep here. So he left his house on a cold day, and seconds after he'd gone out, he slipped on the icy ground. Why do you think Paradeep fell over? Yeah, so ice does not create very much friction. Therefore, there was not very much friction between his boots and the ice, and therefore he slipped over. Now let's watch a video together from BBC Bitesize to think a bit more about friction. If you, at the end of this video, would like some more information and some more activities to do with friction, then there is a link to the BBC Bitesize page in the description of this video.
You've got the golden armadillo! Quick, go before the dragon catches you! It could be here any minute. Why aren't you moving faster? Friction? You mean the force between the surface of the road and the skis? Oh, that's more like it. How come you're going so much faster now? There is less friction between the snow and the skis than there was between the road and the skis because snow is a smoother surface. And the less friction there is, the easier two objects slide across each other. So, just to be sure I've got this. Smoother surfaces means you go faster because there's less friction between them, and bumpier surfaces means you go slower because there's more friction between them. Do you know, I'm not even sure this dragon's coming anyway.
So now we're going to have a bit of a go at an activity where we think about times when friction is useful or not useful. So you need to find from your pack this sheet, okay, and you also need to find this sheet. Okay, so pause the video here and find out these two sheets, and then you need to cut this one along the lines so you've got lots of little bits that look a bit like this. Okay, so now you've got your sheet all cut out, what you need to do is sort these things into whether they have a lot of friction or not much friction, and whether that friction is useful or not useful. Okay, now the answers will be at the end of the video, so make sure you've had a go before you see those. Let's have a go at one together to get us started. So let's start with striking a match. So do we think striking a match has friction? Yes, it does, doesn't it? The friction between the head of the match and the sandpaper that's on the side, the friction causes the match to catch fire. So is that a useful function of friction or not useful? That's right, it's useful, isn't it? Sailing. Now, between the boat and the water, is there a lot of friction? What do we think here for? I think there isn't much friction because the boat slides through the water. Imagine if there was lots of friction, the boat wouldn't be able to move in the water, would it? So, is this lack of friction useful to the people who are sailing or not useful? It's useful, isn't it? Yeah, it's a good thing that there isn't much friction because it means that the boat can sail easily through the water. Let's think about this one. A rope rubbing on a sharp rock. Now, I don't know if you can see this very well. You might be able to look at yours. But what's happened to the rope here? That's right. It's been cut, basically, by this rock, hasn't it? So do we think that that's been caused by a lot of friction or not much friction? That's right, a lot of friction. So the friction between the rope and the rock has caused the rope to break. So is that useful or is that not useful? That's right, it's not useful, is it? We don't want our ropes to break. That would not be good. Okay, let's do one more together and then you can all have a go on your own. Right, here we go. Slipping on a banana skin. Does that have a lot of friction or not much friction? I agree, not much friction. Because the reason it's slippy is because there's no friction. It's like walking on ice, isn't it? And is slipping on a banana skin useful to us or not useful? That's right. It's not useful, is it? It's not helpful to slip on a banana skin. So we put it in the non-useful column. So now it's your turn to sort out the rest of the pictures. Okay, Year 4, we are going to do a car ramp investigation. So our investigation is going to be on the effect of friction from different surfaces on the distance our car will travel. So we're going to hold our car at the top of the ramp, let it go and see how far it travels. But our investigation is about friction from different surfaces. So we've got 4 different surfaces to test. Our first one is made of foam. It's quite smooth. So we need to think about how much friction will this smooth surface create. Our second surface is made of wood. Oh, this one is very slidey and slippery. I don't think this will create very much friction at all. What do you think, Year 4? Our third surface is carpet. It's quite rough. When I run my hand over it, I can feel that it's quite difficult to move. So I think that will create quite a lot of friction. Our last surface is sandpaper. What do you think, Year 4? How much friction will this create? It's very rough and difficult for me to move my hand over it. Okay, so to set up our experiment, we've got our stand for the ramp, and we are always going to put our ramp on the top so that it is a fair test. So the ramp will always be at the same angle, and then we are going to always measure the distance of the car with this measuring tape, and it's going to stay at exactly the same point here at the bottom of the ramp. Okay, so before we complete our car ramp investigation, we need to write down some of our information. So can you pause the video here and find out this sheet or sheets from your pack? And you can write exactly what I'm writing, what I'm going to model for you, or you can write your own ideas, that's absolutely fine. But we will fill this out together now. So our first thing we need to fill out is, what is our question? So what we're looking at is how the friction of the material on the ramp affects how far the car will go. So our question could be, which surface will make the car go furthest? So our next part is I will measure. So what are we going to measure, Year 4? That's right, we are going to measure the distance the car goes, the distance the car goes in centimetres. Well done. Now, we need to make our predictions about which surface will make the car go the furthest. So we've got our 4 surfaces that we just looked at. So we've got foam and wood, sandpaper and carpet. Now you all need to have a think about which one do you think will make the car go the furthest and which one do you think will make the car cover the least distance? I think the foam will make the car go the furthest. So I'm going to put a number 1 there. So you put a number 1 on which one you think will make the car go for the furthest. Then after that, I think it will be, maybe it's the carpet that will make it go the next furthest. Then the wood, because that was quite shiny and slippery, wasn't it? And then I think the sandpaper. Do you agree with me, Year 4? Write down your own predictions. Okay, they don't need to be the same as mine. So have a think about which one do you think will make the car go the furthest. Now we need to think about making our investigation a fair test. So we talked about this before Year 4, if you remember, in our science investigations last term. So to make things a fair test, we need to keep everything the same apart from one thing that we change, the one thing that we're investigating. So what is it that we will change? Let's start with that. That's right, we will change the material of the ramp. That's what we're looking at, aren't we? Yeah? So that's our one thing that we're going to change. Now I'm going to write some things that we keep the same. You might be able to come up with even more things than I can. But things that we're going to keep the same are the angle of the ramp, because we've got that stand, haven't we? So we can make it exactly the same each time. The angle of the ramp, the car we're keeping the same. We're going to use the same car every time. The surface of the floor, the material of the floor, we're keeping the same. The place that we're doing it, we're keeping it the same. And we're also keeping the same the way it's measured, aren't we? We're going to measure it with the measuring tape every single time. The way it is measured. Okay, now we just have to do our experiment to get our results. Okay, so we're going to start our investigation. Make sure you've got your results sheet here with the different surfaces ready to go. So surface 1 is foam. Let's check how far did the car go. I've got my ruler here so I can be accurate. Let's look on our measuring tape. How many centimetres did the car travel? We can see 30, 31 centimetres. Okay, so in our results section, under surface 1, foam, we're going to write 31 centimetres. Okay, now we've got surface 2, which is sandpaper. Okay. Oh, that didn't go very fast at all. I wonder how far it travelled if it was less or more. So, 24 centimetres. Well done. So on our results sheet, under surface 2 sandpaper, we write 24 centimetres. Okay, surface 3, we've got wood. Let's see. Whoa. Let's see how far the car went this time. Can you tell, year 4, how far did it go in centimetres? 41, 42, 43, 44 centimetres. Under surface 3, wood, we're going to write 44 centimetres. Okay, so our fourth and final surface is carpet. Whoa, that didn't go very fast at all. Let's check. How many centimetres did it travel? There's our 10. So we've got 19 centimetres. So under surface 4, carpet, we're going to write 19 centimetres. So for the final part of our investigation, we need to look at our results and decide which surface made the car go the furthest. We need to answer our question, don't we? So have a look. Which surface made the car go the furthest, year 4? And when we're writing our conclusion, we can write, I found out that surface number, whatever you think, made the car go the furthest. Now, if you want a super challenge, you could have a go at talking about friction in your answer. So which of these surfaces do you think had the most friction and which do you think had the least? And how did the amount of friction that the surface created affect the distance the car went? And I look forward to hearing your answers on Zoom later. You could have a go at home at making your own ramp experiment. All you need is some different surfaces and something either with wheels or something that slides and something to measure your distance with. Could be a ruler, could be a measuring tape, but make sure you ask an adult before you do anything.